This is a session called We Can Make Dreams Come True, and hopefully everybody's in the correct place, correct time, right? Okay. Just a little quick disclaimer that any video or audio I show off is going to be just for teaching purposes, and some of the versions that I'm showing here might differ from the versions that you use or that you get, some of the functions and some of the look and feel of things. And some of the things I'm showing are just generic data sets and non-confidential. So about me, my name is David Taylor, and I work for Metso Minerals Industries as a global systems specialist. And I'm on the engineering applications team, so we roll out software, we deploy software to everyone, and we help support and train everyone. I'm also kind of a person that likes to do the R&D of the new engineering products and processes. So working with that with Autodesk generative design, 3D scanning, laser scanning, reconstruction, things like that. And then also I have a side business for Developed LLP, and I'm a co-founder of that and a chief development officer, so anything that goes to market has to go through me. And then with that, we do mobile and digital apps and rapid prototyping too. So some of the things that we're doing at Autodesk Generative Design, I work a professional life and on my side business also with the 3D printing and additive manufacturing. So before we start, I have a little bit of trivia here, just to get everybody involved. And if you guess it right, you get one of the Hershey's candy bars here. So raise your hand real quick if you know the answer, and then I'll try to get you the bar, okay? So, what movie had the quote, "We are the music makers and we are the dreamers of dreams"? You'll see a whole theme about this. Anybody know? Was it, hold on, what was it? The Matrix? The Wizard of Oz? Willy Wonka and the Chocolate Factory? The Godfather? Or I Have No Clue, You Crazy Fool? Who knows? Anybody? Willy Wonka, yes, you get your chocolate bar. So come see me afterwards, you get your chocolate bar. Okay? So that's going to be the theme for today, all right? So remember that. Yeah, Willy Wonka, okay. With your golden ticket, you got a golden ticket. Hopefully there's a golden ticket in there, maybe. All right. And why my fascination with this movie and this theme? Well, the Willy Wonka factory looked a lot like the place I grew up near, Hershey, Pennsylvania. If you can see the resemblance. And I always thought as a little kid when going there, I thought, oh man, it's got this great, chocolate factory on the inside. I can go eat everything in there. And when you actually visit the place, they do have a little tour. You can go visit. So that's, ever since I was a little kid, I've always been fascinated with that movie and with everything like that.
I'm older than you were. When I was younger,
Yeah.
they took me to the real chocolate factory.
Really? Okay. I think you can sign up for a little bit of, some tours for that still go, but yeah. Yep. But if you ever get a chance to go there, it's great. You get to smell the chocolate, eat all the chocolate you want. But all right. Now let's now you know a little about me. Let's move along. About all of us, we're going to have a motto for the session: that we are the dreamers, Autodesk makes it plausible, and generative design makes it possible. Okay? So everybody knows the clip from Willy Wonka, right?
Well, 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 2 naughty, nasty little children gone. 3 good, sweet little children left. Hurry, please. Long way to go yet. Oh, wait a minute. Must show you this. Lickable wallpaper for nursery walls. Lick an orange, it tastes like an orange. Lick a pineapple, it tastes like a pineapple. Go ahead, try it. Oh.
I got a plum. Grandpa, this banana's fantastic. It tastes so real.
Try some more. The strawberries taste like strawberries. The snozberries taste like snozberries.
Snozberries? Who'd have heard of a snozberry?
We are the music makers, and we are the dreamers of dreams.
Boom. And there was the quote that I like, okay? At the very end there. And little people, and people know that, people really don't know that there's an actual poem that's from. It's a poem from 1863. It's, we are the music makers and we are the dreamers of dreams. wandering by lone sea breakers and sitting by desolate streams, world losers and world forsakers on whom the pale moon gleams, yet we are the movers and shakers of the world forever it seems. So I like to think of us as the movers and shakers of dreaming up designs and making designs for our companies or for our personal lives. So moving from that, everybody's here for generative design, right? So what is generative design? If you just think about it, nature has been perfecting and adapting design for millions of years. Close-ups of butterfly wing, dragonfly wings, mushrooms, eggshell. Just look at the structure, how it's formed. Not many people think of this when they think of the products around us. There's a couple more. Bone structure, broccoli. Anybody ever think broccoli looked like that? Close up. Shells, leaves, beehives. So we can dream it. What if we could reference nature for the basis of our design? Generative design mimics nature's evolutionary approach to design. It's designed with a purpose. Just like nature has a purpose to build their items, we have a purpose to design and build. Next will come a little video that Autodesk put out. I think everybody's seen it
What if you
maybe
could
last
come up
year,
with
but we
thousands
can
of
take a look at
options
it.
for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
Now, when you look at that video and you hear it, it says half as light but just as strong, or it could even be stronger, just like bone material. Everybody, we saw the bone structure close up there. It's really light, but yet it's really, really strong. Generative design is going to help us optimize and create designs that we can only dream about. A human being couldn't design that, but with nature's approach, with their algorithms, we can create designs that we can only dream about. So everybody's here now for an instructional demo. I'm going to show you how easy it is, how simple it is to start your project, get some models in there, and then generate and create some outcomes. So we're going to get started with it. We're going to do the demo. We're going to load projects and models into the software. We're going to set loads and constraints. We're going to set objectives and see how simple it is, and we want you to use it and then give us some feedback about it. So when I was starting out, I started with this bracket, Nemo bracket here, little motor bracket. And my first try putting this object into generative design, I get something like this. Don't laugh. Okay? Can I use that in production? I don't think so. No, it looks something like a weird antlers or something. But I learned about the software. I tried more and more, and I got something on my 10th try that I could actually use. So going from the NEMA bracket up here, this bracket up here, down to something like this, and if I created that in steel, I could get something just as strong, but half the material. Actually, it's more than half the material gone, and the weight also is down to about 30%. So starting with Autodesk Generative Design, and if I say AGD, it's going to be a little bit simpler also, instead of saying Autodesk Generative Design all the time. All right, so if you think about that, just remember, okay? So we're going to start the generative design, we're going to start that, we're going to log into our account, and then select the hub and click our new project. So with that, we'll start the software. We're going to log in. Okay. Now we're in the tool. Now we're going to go up to our profile here, our profile button, and you can see that there's different hubs that you can select from. Different teams. Okay. Now if I go over here to the new projects button, I can see the different generations I've done in that hub. Or I could go over here and I can switch hubs again and then see what I have in the other one. So you could create different projects for different teams, different hubs there. Okay, and you click the new project button and you're ready to start to go. Now with generative design, there is a user interface and workflow. And Autodesk recently in the Tech Preview 5 just put a new starting video in here to help you out. So once you first start it, it'll show you exactly what workflow you have to go through to get your generations and outcomes and see what you can do to filter and explore at the very end. Nice little addition they put in there. Okay. There's a user interface, so there's right-click menus. There's different key combinations, control left clicks or add to selection, shift middle mouse rotates and control middle mouse will zoom. So it's really similar to CAD programs you have already, and it's pretty familiar. And you can also do the quick tour button there if you ever have to do it again or look at it again. There's a quick tour button in the question mark icon top right. There's also preferences in generative design. There's global unit preferences and project unit preferences. And the project units will only show up if you have a project started. So if you start the tool and you look in there, it's only going to show the global units. And there's priority over the global units with the project units there. And there's a clear workflow. So if you watch the video, there's a clear workflow from left to right, from importing your geometry and setting loads and constraints and objectives, then generating it. So here's the tool, and you can actually see some of the buttons and the workflow. All the way to generate. And there you can, on the left-hand side, there's like a browser tree that you can look at all the parts that you have. You can select the parts. You can click on a little eyeball to toggle visibility. You can right-click also, like I said, the right-click menus to assign or toggle visibilities. You can also rename the imported CAD objects so that you know what they are. And there's the assigns. Okay. Now there's a clear structure within the AGD the file structure here. You start out with the hub. Like I said, you could switch hubs or teams. And within that hub, there's a project. So you start out with a project, and then you assign a study and loads and objectives within that study. So just like here on the browser tree, just broken down here. Okay. So with our first task that we have in the AGD software, it's importing and assigning geometry grids. We need something to start out with. We can't just say, hey, push the button and create something because it doesn't know what to do. So we have to import geometry. The supported formats for import are your mesh and standard formats, which are like your SAT files, your IGES files, STEP, STL files. I think they're the most used, maybe OBJ. And since I was using Inventor for a lot of export and importing these meshes into AGD, I found some key things that if you're using IGES or STEP or SAT files, when you export from Inventor, it won't include the mesh features. So you have to, in Inventor, create a solid body using like a mesh enabler add-in or something else. You gotta have that solid body to export from Inventor. And then with the SATs, it will treat the bodies as one entity. So if you have multiple parts in your assembly, it will just come in as one full singular part. It won't let you select different parts, different bodies. And with OBJ and STLs, it will actually not, when you export it from Inventor and you import into AGD, it won't show you these little geometries that are inside the other bodies. So they're just some tips that I have found from working in Inventor and with AGD. So right now, it will show here how to import and what happens. So I'm going to import the motor bracket. Ask me for units. You can select the units there. And it imports as the separate bodies here from the assembly from Inventor, which I chose there. Okay. And when we're assigning geometry, we have, it's giving instruction to the application. So it doesn't really know what to do after you put the geometry in there, so we have to assign some things to it. So with the preserved geometry, it will keep the geometry the same as what is designed. So if you select a part as preserved geometry, it will keep that for the outcome also, the same exact shape. The obstacle geometry creates like a barrier. So you're going to have obstacles within the design that the generative design software is going to build around and not butt up against that, but not go through it. And then we got starting shapes, which is the part or the geometry that we want generative design to modify, to build, to recreate. So there's 3 different types of geometries you can assign, and it tells kind of the software and the algorithms what to do. So you can see here in this, we're going to assign some geometry. So we got the preserve, obstacle, and starting shape. So I'm going to assign a starting shape. I want that bracket part, that full part there, to be recreated by the software. And now I'm going to assign an obstacle geometry. So with the holes that I wanted the motor to come through or the bolts to come through, I had to create these extra pieces of these extra bodies. And I'm assigning those now as obstacles so that the software won't make anything through those holes. And now I'm turning off that full starting shape so that I can see everything underneath and inside. And with these, I want to create the rings that the bolts where the motor goes through. That's my preserved geometry, and it will actually keep those rings in my final shape. Okay, and you can see they change different colors just to denote the different types of geometry that you assigned. And over on the left-hand side, you can see in the browser here, you can see the different geometry that's assigned to the different types. Okay, some tips for assigning geometry. When you export your CAD model, you got to make sure you include your starting geometry, of course, the thing that you want AGD to recreate. And sometimes you need to define, preserve, and obstacle geometry from your CAD, original CAD software. So like Inventor, I had to go and create these extra obstacle geometries and these preserved geometries for the software to keep or to build around. And like I said, you might need to go back, do some outcomes, go back and then have to redo it in CAD and then export and try it again. The software, the AGD software is really quick at creating outcomes, so to do that, it's pretty simple to do. Okay. So after we imported the geometry and assigned the different types, we have to set constraints up for it. And with this, we can do a fixed constraint, which we can select bodies, faces, edges, or vertices. And we can set a fixed direction through fixed directions of X, Y, Z if we wanted to. We can click those off and on if we want. And here you can see I'm going to assign a constraint. And there's all the different types of constraints you can assign to the different bodies. And I'll select the body. And now on this, I actually set the constraint on the around the motor, so because I wanted that to stay where it was, and also on the bolt holes. Okay. So after we have constraints, we need to set up loads because we go our workflow left to right. So we go constraints, now with loads. And there are three different load types. There's a pressure load, a force load, and a moment load. So I like to think of these as squeeze, push, and twist. Okay. And we can apply these to certain loads to selected entities. So depending on the tool being used, the load being used, you can set them to faces, edges, vertices, or bodies. And also, with the project units and the global units, if it comes up as if you can see in these little boxes over here, if it comes up as newtons or pound force, you can actually type in the different type of unit in there. Just type it in manually, and it will convert it automatically for you. So right now I'm going to set a load. I'm going to do my force load. You could, left click is just to select it, then you can do control click to add or remove. For these? Oh, yeah. It would be face, edge, vertice, or body. Yeah. And you can see I actually put in pound-foot, LBF, instead of newtons because I didn't necessarily needed to convert it. I just typed it in and it did it for me. So I'm going to now add a force onto this bottom part here. Okay, now I've got my loads on there. So now I've got my geometry, my constraints, my loads, and you can see that the loads show up here in the browser also. So as we work this way, it's also working and building everything on the left-hand side here. So there's multiple ways of doing this. So you can see as you work with the tool. Now we've got objectives. The next button over. We've got objectives. So types of objectives are, this is the thing that you want to achieve from your design. You've got minimized mass. So with that, you can specify your safety factors, and you can that will make it the lightest weight possible within that range. You can also set a mass target. So that's like I want it 30% difference from my original design. I can set that, and it will go within the safety factor that you create. And then also you can maximize stiffness. So you specify the safety factor, and it gives that an optimum rigidity to weight ratio. And with the maximized stiffness, you can actually create another objective then too. So you can have two different ones going at the same time. Okay. Now, next button over would be manufacturing. Manufacturing is the type of way that the object is going to be created. So you can do unrestricted. So that means it's any type of way that's manufactured. 3D printing, casting, whatever you want. Then there's additive selection also. So if I just want additive manufacturing, so I'll just click on that and say I want to do like a 3D printed object, and it will actually optimize the design for additive manufacturing. Next one over is materials. And with materials, you can select a maximum of 5 materials. There's a materials box that pops up when you click the button, and you can, if there's a little red dot there, you can download more. That there's every week or every couple weeks, there's more and more added to the software. So it's pretty good, pretty quick. And then you can click on each material also and see the specifications of the material. So if you don't necessarily know the strengths or the weights, then you can look at that. And one note too, custom materials cannot be added yet, right? Not yet. Okay. A lot of people ask for that, but we'll see. So here's the material box, and you can see I'm now downloading new materials from the cloud. It's adding them directly to the pop-up. Then I can select those too if I wanted to. So it's as simple as that. Really, really quick and easy. And they're just scrolling down through all the materials that we have available within AGD to use. Okay. Now there's another button, or not a button, but there's a part at the bottom of the browser tree, and that's called synthesis. And that is about what topology you have at the very end of your outcomes. So it will give you 3 options. You can have a coarse topology, which is reducing the time for generation, and it will just give you the a quick outcome. But it's the least accurate, it's just like a draft And then there's a normal selection, and that normal selection will optimize the outcomes along the spectrum. And then accurate is the best quality and desired for manufacturing. So once you hit generate, it will show you a number of outcomes. If you have a lot, I would try to go with the course just to see how quick it goes and see what you get on the output. And then once you have something that you want to use, then you can go with accurate. And once we have those set up, we can go ahead and generate the job. And with generation, the data is checked first, and there's errors that get shown. So if you have a little red icon next to an item on the browser tree, of course you have to go and fix that, whether a load is off or constraint is off. You can roll over the icon, it will tell you kind of what's wrong with it. And then if there's once you hit the generate button, if there's any cloud or other messages, they're returned in another little pop-up button there. And then next to the pop-up button, there's a little status icon. And with that, it gives you the generation status. So uploading the file, going through it, and also you can also cancel if you need to stop something and go back and resend it. So you can see here, I'm going to go ahead and try generating something. And it checked. And you can see now I have a little red icon there. So I needed to fix something. And it will tell me exactly what I need to fix. So my first couple runs, I had a bunch of these because I didn't really set things up right. So trying to work things out and get it clean. And if your data is good and your specifications are good, the pop-up will come up, and it looks something like this, of telling you how many outcomes you're going to have. So the more things that you add in there, the more materials you add in there, the more manufacturing constraints you add in there, and the types of synthesis resolution, it will depend on, the outcome number depends on that. And after you click the generate button and you hit the continue, it will upload your study data to the AGD cloud, and then the magic begins. So you can see here there's a clean generation. Once I hit generate, it comes up with the pop-up window, and it tells me how many outcomes I have right away. I hit continue, and now it's starting to upload and generate my designs.
Can you explain when you had to put a body constraint on the part of the geometry that you didn't want to have changed at all?
Yeah, so like the hole where it was bolted in, I didn't want those to move, and I wanted to keep them as the same pattern, pretty much. So I put constraints on those so they wouldn't move, the software wouldn't move those around.
So even though they're identified as don't move them, they're just like the geometry stuff with constraints.
Yeah. And here you can see now that the outcomes start to pop up in your Explorer tab here. Okay. Now, some results after that. We have outcome filters within the results. We can filter by status, we can filter by studies and objective ranges. So we can drag these around just like sliders, drag them around and get our ranges for mass and volume. And there's different types of views within the Explorer tab. There's a thumbnails view, which gives you just thumbnails of all the outcomes. That's the simplest view. There's a properties view that will give you all the different types of property details underneath that, underneath the thumbnails. There's a scatter plot, which is a nice view of, so you can set it up by status, whether it's done or not, or you can set up different criteria on the table, left and right, up and down, left and right, and you can see where they lie on the scatter plot. And there's also a table, so you can sort and filter out that way too.
Can it inadvertently generate designs that are not producible on your output device? Do you have any information about that kind of constraint? That where material would get too thin or something?
Do we?
Are you after a specific machine or?
Like a wall thickness maybe, or yeah, you have you know an output device that may have material that can be extruded to thinness. This might recommend a design.
Yeah, so I mean, at the beginning you can put in like a number of those, so you won't go thinner than that, but it's like a machine that would agree whether you transfer it. Yeah.
So with the views then, we can see here in the Explore tab, we've got the filters on the left-hand side, and we can view by our processing status. So as it's going, we can take a look at what's done, what's still going, what's failed. And there's our drag there on the filters, that we can sort and filter that way. And we can also filter them and sort by the drop down there. And there's our icons for the different types of views. So if you click through those, there's our properties detail, and there's the details underneath. And here's our scatter plot, and as you roll over each one, it shows us the design, and also it shows us the information on the right-hand side. And once I click on one, then I can see that information. And here's our table view. And by that, you can, just like in an Excel sheet or other tables that you're familiar with, you can sort by the columns. If I were to double click on one of the parts, I can actually open it up in a 3D view and rotate it around and take a look at it. I'm thinking the software didn't need those holes for the structure because of the strength that it would just needed those back holes to, with the forces that I put on it.
Was this generated in the accurate setting or
The normal setting, yeah. Okay. Failed is if the geometry disappears, right? Yeah.
There's many reasons for
Yeah.
failure. What I thought it isn't so we're just kind of iterating how people want to solve it. But anytime like structures become disconnected, like sort of seizures and disconnect pattern, that can be theoretically classified as failure. So we have to mark that and tag it and show you. Or sometimes the solver will time out if it's trying to iterate on something that is spin it out of control sometimes. So I won't call it out of control, but it's just waiting too long. And so that'll fail too, and it'll get kicked out, and it'll warn you that. So we're just kind of on the back end trying to figure out how to balance all these solid things, so we make sure we do the best.
Okay. And here, opening up, it actually can, in the newest TEP preview, they show you the stresses on the object. So you can take a look at that, and you can turn those off using the button here. Okay. So you can see stresses, and then also in the newest tech preview, they have you can sort by materials or have a scatter plot of materials so you can drop that down and see what types of materials they are on the plot. So with the example I just showed through here, with steel material, I had my original part, which was heavier and had more material used. And my stress factor actually on some of the points was doubled compared to this part here. And with this part, it had a higher safety factor, 39% of the mass compared to this original part here. And it had less areas of high stress, and in those areas it was considerably less stress. So I had more example outcomes. These are just things I tried putting through and testing within the software. They might look a little strange. Here's a motor bracket with that's supposed to hold the gear guard for that bracket. This is one of the other results for additive manufacturing from that NEMA bracket. And this was actually a roller I tried doing with the loads and constraints within AGD. Building it almost like bone structure that would hold up the other rollers that sat on top of it. So after we have a product, an outcome, we can pick that and then we can export it to other CAD also, like back to Inventor or to another CAD software. So what we would do is we would pick the outcome we want. And with that, you can take this little dragger, this little drag down here, and go back iterations, because the software will iterate the design as it goes and as it generates. I can go back to different iterations and view those. I can then click that little button at the top right-hand corner up here, and I can export it as an STL file, or I could use it in another CAD application. Then I can also go to a different iteration and do the same thing. And save that one also. So as it goes back, I can save those separate ones, and I can open them up then. This is Inventor. I can open that up in Inventor and use that for design. Or with Fusion. I can find the object, open it up, and use that as a design. Then from Fusion too, I can then export that as different file formats also, if I don't want STL necessarily. Okay. And then there's some further learning and help within the AGD software. There's like I said, that question mark icon, and that's got some online help. There's a link there. There's also the Autodesk feedback community forums. You could go and check those out. And also today, I will be available if anybody wants to meet me at 5:30 here in this classroom. Just let me know after class, and I can talk to you about the software, or if you have any questions, you can come to me about that. And there's another question. Where can I get it? Well, the ID Exchange. You can sign up through the website, Autodesk IDX, or it's in the across from the exhibit hall. You can go there and sign up for one of the Autodesk generative design sessions, and then you can get a tech preview. Yeah, yeah, and there's David here, who is the person to talk to if you want to get a sign up for that. Okay. Yeah, and with that, you just meet one-on-one with the idea exchange, and then it's about 20 minutes or so to talk, and you'll get a invitation to the preview. And now with that, you have the golden ticket to start your own projects, start your own products. And if you see down on the casino floor, they had the Willy Wonka stuff too, so I thought that was pretty neat, sticking with the theme. I got you first. All right. Okay, so you get the second one, so see me afterwards. All right. Another lab going on tomorrow, hands-on with Autodesk Generative Design. So if it's already full, just go wait outside. You might have some openings to go through there to get in there. All right. One other thing, fill out your surveys. You can complete them online or on the AU app. Okay, always do that. And if there's any questions, we've got Doug here from Autodesk, who knows everything pretty much about the software. So if you have any questions, feel free to ask, and we can try both to figure them out. Yeah.
Do we know when it's available?
So right now it's in tech preview, so you have to register for tech preview if you wanted to acquire it. I think we just announced, so in tech preview it's available to NetLab Ultimate customers. We just announced today that it's going to be available to Fusion Ultimate customers as well. But if you're neither of those, you can request access through David and myself, and we take those on a case-by-case basis. So as far as commercial availability, I can't say it.
Hey there? Yes.
You've got a lot of different configurations being generated there. Is there any kind of guidance as to the best optimum configuration amongst there, or the best kind of trade-off within there? Or, in other words, how do you pick your particular component from that?
Yeah, I think the best one to look at would be the scatter plot, or yeah, yeah.
Your objectives are, right? So you're putting in your objectives as far as what you're wanting to achieve, and at the end of the day, you as an engineer or designer can balance that decision. So surveying all those different options and choosing, it could be aesthetic reasons, or it could be maybe I was really looking for something with minimum mass. That's kind of up to you, right? We don't want to take that away from you, I guess, as an engineer or designer. I think that ability to make decisions on the fly and work with the software is something that we think is important. We can validate that with the group.
But the no-shows or the no-goes, are they kind of eliminated from your choice? So you're left with like valid choices?
Yeah, so
Yeah.
anything that would not fit those requirements wouldn't be shown to you. So everything that fits your objectives is on the screen.
Yeah. So like I said too, within the software, for me, the best view to see everything that I want, the optimized designs and everything, was the scatter plot view, because then I could pick, depending on, this would be like safety factor to weight ratio. And then I could pick on the plot which one I wanted to choose, depending on, I would just choose, okay, this has the highest safety factor, I'm going to choose that one, or this one has, kind of in the middle of the range I want. I can choose that. So it's really up to you what you want. Yes.
Is there a way to instruct it to follow a line of symmetry so that you don't have parts that are unmeasurable in drawing? Instead, you can just tell it, short of cutting a part in half, putting a plane, cutting all your values in half, and then just mirroring it. Is there anything around that?
We're working on it right now.
Mm-hmm.
That's going to be an answer to a lot of your questions.
That's it. That's fair.
Yeah. Yeah, I think that's been a big question. Yeah.
Do you guys have any way to I know you can't tell us what the cost would be to make it, but the model kind of manufacturing costs, so you can sort those by difficulty to manufacture.
We're working on that right now.
It's a new tool, so it's
One comment on that one. You notice that is probably the largest driver for selecting something that comes out of the project, right? So we definitely want to be able to plot that on that scatter plot to show you what the relative costs of each of those would be. Yeah.
Because as you can imagine, when you go from a standard we draw
Mhm.
Totally get it.
Yeah. Any other questions? Yes,
I
David.
have a question. Great presentation, by the way. You mentioned there was 10 attempts, 10 trial and error attempts
Yeah.
to go from your first project to what we saw just now.
Yeah.
So some of it seemed like it could have been tech preview bugs or
Mhm.
issues, but I'm wondering what might be included in the learning experience to sort of reduce the number of iterations to yield the results
Yeah.
that you were looking for.
I think it was mostly the obstacle geometry or the preserved geometry, just knowing what exactly to put in there so that the software wouldn't build into that, or because a lot of like I said, the first one that looked like antlers, it didn't really have any of the preserved geometry or obstacle geometry in that, and it gave me really nothing I can use. But I think with the 10 different iterations I had to either make the obstacle geometry bigger or smaller, depending on where I wanted the software to build around. Yeah. I think there's some feedback on that from everybody else also. Yeah.
I guess there's one thing that I might view as somewhat of a difficulty. Most of our clients require everything to be documented.
Mhm.
There are shapes there that you can't document. If you're designing these parts and fabricating them yourself, that's fine.
Mhm.
But I mean, it may not be the answer to this. How do you come up with a shape like that? Hey, it meets all your codes.
You mean putting it in like a drawing or something like that? Yeah.
You got some curves and stuff
Yeah.
over there that are undefinable.
And that's where, Inventor or something that comes, where I showed you, import it into Inventor, and then you can create a drawing right off of that, place the views into the Inventor drawing, and then just take dimensions off of that. But
Probably put some general dimensions.
yeah. I think with something like that, though, you wouldn't be able to make it by just looking at the drawing. You'd have to send almost the CAD model to the factory to make it.
Something else that we're working on, again, is the ability just to export those directly to the CAD. Right? So this is something that we've noticed that really has to happen, is at the end of the day, whatever comes out of there, you're probably going to want to change it. Right? So this is more of a guidance rather than this is the best thing that you could have. And that's kind of how we treat it, especially for those kinds of circumstances.
Sort of best practice to sort of model more geometry. I mean, your example was
Mhm.
you took bracket and then you wanted to sort of create a better bracket.
Yeah.
Would it be best practice to sort of model the most geometry that would fit into the space with those keys, connection points that say, make me that bracket.
Yeah.
So there's two workflows to this. And we didn't really call it out. You don't really need the original bracket. You can just go in and say, these are my connection points. Just build this. So if that's what you want to do, completely. Right? But the other way to do it, like how David was explaining, is
Mhm.
completely valid. And what you would find, I think, is if you put more geometry in it, you find geometry that didn't need to be there. So like how it removed those two ports, right? It's interesting the way that you interact with it. It's a different way of thinking about that design. And just there's usability things that we explore.
Yeah. And I think with your original design, you also have to deconstruct it as what do I want to keep, like the original preserve holes. I had to create those separately of what the original bracket was, because I wanted to keep those only and preserve those. So I had to add extra geometry to my model there for it to keep those. But you can almost take like your design that you have and then just kind of cut it up in different places and then say I want to preserve this, or I want to make this obstacles, or make that change.
I think what he was getting at is just the question of how much does your input data or your input model affect the outcome.
Mm. Yeah.
So if you start out with something versus starting out with just giving you a block of material.
Yeah.
Yeah, it's totally true, right? So the way you set up a problem and define a problem completely changes what it gives you, which is part of the fun.
Did you try running the same thing without giving it any geometry?
Not in this example, no.
I was curious if it would come out the same.
Yeah, it would, yeah. Plus, I probably wouldn't be able to fit in the space that I tried to have for the motor, so.
If you run the same settings 3 times, will it give you the same result?
It's the same exact problem setup, yeah. Yeah, it's that stable, I guess. If you want to know the difference between open, we called it open design space with no previous geometry and closed design space with a starting shape. That hands-on labs one goes through all this, discusses it in great detail. So it'll be a really good lab.
Like for additive manufacturing, non-homogeneous materials in the future?
That's a good question. Actually. Yeah. You're talking about fiber build? Yeah. Yeah, we'll get there. Right? We'll get to polymers, things like that. Where that's a little bit.
Mhm. Yeah, and then like I said, if you want to sign up or take a look at everything else, I'm sure you guys would be happy to sign more people up, get more feedback on things, and then you can, be on the forefront and see what's going on and what's getting added all the time. Any other questions? No? Okay. Thank you.